Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is polynomials. This is the second video on polynomials and the previous one contained the concept building for the topic and a few solved examples were also given so that fundamentals got cleared. In this particular video, we are focusing on extra punch problems which are examination oriented. So pay attention here students. Find zeros of the polynomial x square minus 3 plus 2x. I suggest student first you pause the video and try to solve yourself. If you are unable to solve, please go through this slide. Now let us first write the problem in standard form. So what is standard form? First the highest degree term will be there x square, then the next highest degree which is 2x, then the constant term, and equal to 0 we have put since we are finding the zeros. Finding 0 means what value of x will drive this expression to 0. So the advantage of using standard form is that we can directly apply the formulas. So once we get this, we'll find the zeros using factorization method. So what is factorization method? We'll split the 2x term such that we get a product of 1 into minus 3. 1 is the coefficient of x square and minus 3 is a constant sum. So product is 1 into minus 3 which is minus 3 and sum will be 3 and minus 1. So 3 minus 1 will be 2. 3 into minus 1 will be minus 3. So we split it as x square plus 3x minus x minus 3 equal to 0. Now let us take x common. So we will get x square x into x plus 3 then minus x plus 3. If our splitting is correct, then we should get two identical terms here. So we got x plus 3 as the common. So this term is 1. 1 can be put here. So if we take x plus 3 as common, we can write x minus 1 into x plus 3 equal to 0. So this means either this is 0 or this term is 0. So if x minus 1 is 0, we'll get x equal to 1. If x plus 3 is 0, x equal to minus 3. So we got two roots or two zeros as 1 and minus 3. We can cross check also. We can put the values, say 1 here. So it will be 1 square minus 3 which is minus 2 plus 2, so which is 0. So if we substitute again minus 3 here, again this term will become 0. So it means our roots calculated are correct. Let us take another problem. We want to find a quadratic equation whose roots are 2 plus root 5 and 2 minus root 5. We know through a formula that to find the quadratic equation from the roots, we have to use this formula x square minus sum of the root x plus product of the root. So what is S? S is sum of roots. So sum of root is, we have to add these two. So 2 plus root 5 plus 2 minus root 5, root 5 term will go. So we will get the remaining term as 4. Now what is product of the roots? P, which is 2 plus root 5 into 2 minus root 5. So a plus b into a minus b is a square minus b square. So a square will be 2 square which is 4. B square will be root 5 square which is 5. So 4 minus 5 which is minus 1. So let us substitute S and P in this formula. So x square minus 4x minus 1 is equal to 0. So this is our required quadratic equation whose roots are this. Now I want to put a challenging problem to you. Suppose you are given this equation x square minus 4x minus 1 equal to 0. I request you to find the roots and get these answers 2 plus root 5 and 2 minus root 5. It will be a really challenging work. I hope you can do it. Please take it as an exercise. Now we come to another problem. We want to find the line y equal to 0 will have how many zeros? So let us try to understand first. Let us take one example. I have drawn a line. These are the coordinates. These two are the x and y axis, and I have drawn a line, say y equal to 5. So how many zeros will this line have? Y equal to 5. Answer is none, because this line is not crossing the x-axis at any point. So this line y equal to 5 is having no zero. Similarly, I take a line y equal to minus 5. It will be passing here. So that will also not contain any zeros because it is not cutting the x-axis. On the other hand, the line y equal to 0. What is line y equal to 0? That is the x-axis. Full x-axis is the line y equal to 0. So that will contain how many zeros? It will contain infinite zeros, because every point on x-axis will be a 0. So the correct answer is infinite. Just I want to add one more question. For example, I have got a question like line x equal to 4. Let us draw a line x equal to 4. So this is a line x equal to 4. So how many zeros will it have? It is cutting the x-axis at exactly one point. So it will have only 1 0. So another problem now, sir. A cubic polynomial will have how many zeros? The choices are exactly 3 zeros or maximum of 3 zeros. The correct answer is maximum of 3 zeros. A cubic polynomial has degree 3. So maximum number of zeros can be 3. It can be 2 also, it can be 1 also, it can be 0 also. In examination, they may also ask you, it can be written as at most 3 zeros. Instead of writing maximum 3 zeros, option could be at most 3 zeros. Coming to another problem. If one zero of polynomial 3x square minus 2x plus p is reciprocal of other, then determine p. So we know that for a standard quadratic polynomial ax square plus bx plus c equal to 0, what is the product of the roots? We know product of the root is c by a. That is the constant term divided by the coefficient of x squared term. So let one root be alpha. Then what is the other root? It is given reciprocal of the other. It will be 1 by alpha. So what is product of zeros? C by a, which is p by 3. C is p and a is 3. So p by 3. What is product of 0? Is alpha into 1 by alpha. So alpha will get cancelled and cross multiply. P will get it as 3. This will be the answer. Now let us solve another problem. We want to find zeros of this polynomial x minus 5 the whole square minus 9. Now one approach could be we expand this to say x square plus 25 minus 10x minus 9. We will get a second degree polynomial. We will expand the middle term and then we solve it. That is what we have learned so far. Now we will try to do it in a much simpler way. This problem is much simpler. Now if we just see this, there is a square term here and 9 is also 3 square. So this is also a square term. So if we have to find zeros, we put this as equal to 0. And we take 9 on the right hand side, we get x minus 5 the whole square equal to 9. Now we need to understand this. Let z square equal to 9. This I am trying to build concept for you. Let z square equal to 9. Then what could be value of z from here? Z could be plus 3 or minus 3. Let us put 3 here. So 3 square 9. Okay. Let us put minus 3. Minus 3 square is also 9. So z can take value either 3 or minus 3. We write it as z equal to plus minus 3. It means z can take either plus 3 or minus 3. Similarly, let us put z square equal to 25. Then z will be plus minus 5. If z square is 64, z will be plus minus 8. So similarly now x minus 5 the whole square is 9. So x minus 5 will be plus minus 3. So let us shift 5 here. So on right hand side this will become positive. So x will be 5 plus minus 3. So how to solve this? Plus minus means once we will take plus value of 3, another x value will compute with minus 3. So if we take plus 3, so x will be 5 plus 3, 8. If this is minus 3, x will be 5 minus 3, which is 2. So these are the zeros of the polynomial. Let us try to put this and see whether it really becomes 0. So first we'll put 8 here. So 8 minus 5 the whole square, which is 3 square, 9, 9 minus 9, 0. Similarly, when we put 2, 2 minus 5 minus 3 the whole square, 9, 9 minus 9 is 0. So these roots are indeed correct. In this problem, we are given that if alpha and beta are the zeros of polynomial this, then find p, this constant term we need to find if 3 alpha and 2 beta equal to 3. Now we are given alpha and beta are the zeros of this. So we know that for a standard polynomial, second order polynomial this, sum of the roots is given by minus b by a and product of the roots is given by c by a. Where c is the constant term, a is the coefficient of x square and b is the coefficient of x. Let us write, if alpha and beta are the zeros, sum of the roots is minus b by a. B is minus 2. So minus of minus 2 is 2. A is 3. So 2 by 3. Product of the root is c by a. So p by 3. We got it. Now let us cross multiply this particular equation. So this will be 3 alpha plus 3 beta equal to 2. That's what we have written. 3 alpha plus 3 beta equal to 2. And we are also given one more equation. 3 alpha plus 2 beta equal to 3. Let us put minus sign here. Why I am putting, we are trying to eliminate one of the variables. We want to eliminate alpha because their coefficients are same. Their coefficients are same. So we have put minus sign here. So if we cut this, we can cancel this 3 alpha minus 3 alpha. Then 3 beta minus 2 beta will be beta. 2 minus 3 will be minus 1. So beta will be minus 1. We can put this beta here in this. So beta will be minus 1. Once it comes here, it will become plus 1. So alpha will be 2 by 3 plus 1, which is 5 by 3. So we got this. Now we got both alpha and beta. We want to get p. Once we put alpha beta values in this, only p will be unknown. So we put alpha as 5 by 3 into minus 1 is equal to p by 3. 3 will get cancelled, minus 5 will remain here. So p will become minus 5. In this problem, we want to find alpha minus beta the whole square, where alpha and beta are again the zeros of the polynomial 2x square minus 3x plus 4. We want to find alpha minus beta the whole square. So once alpha and beta are the zeros, again using the formula sum of the roots as minus b by a and product of root as c by a. So what is a here? A is 2, b is minus 3, c is 4. If we substitute here, we get sum of the roots as 3 by 2 and product of the roots as 4 by 2, which is 2. So how do we get now alpha minus beta the whole square? The thing is that we have alpha plus beta and alpha beta. So we should expand this. what we need to find in terms of alpha plus beta and alpha beta. Then we can compute this. So let us expand this alpha minus beta the whole square. We know alpha square plus beta square minus 2 alpha beta. So if we see RHS, alpha beta is known, already we know, but this term cannot be computed. Through alpha beta we need to, alpha plus beta we need to convert. So what we do in this term, if we add 2 alpha beta, then this term can be written as alpha plus beta the whole square. But we cannot simply add 2 alpha beta, we need to subtract minus 2 alpha beta also. Then this is the remaining minus 2 alpha beta. So what we have done in this expression, we have added 2 alpha beta minus 2 alpha beta plus 2 alpha beta minus 2 alpha beta, and the rest term is kept as it is. So now the first 3 terms on RHS, we can write it as alpha plus beta the whole square, and the balance term is minus 4 alpha beta. So now on the RHS we have converted it into what we have, alpha plus beta we have and alpha beta we have. So once we substitute this 3 by 2 in this, 3 by 2 the whole square minus 4 into alpha beta, 4 into 2 8. So we get it as minus 7 by 4. Now in this particular problem we want to find the number of zeros. So friends, to find number of zeros we need to find at how many number of places it cuts the x-axis. So this is the x-axis, and we see that this polynomial cuts x-axis exactly at one location. So the number of zeros of this polynomial will be 1. Let us take another problem, friends, that if p and q are zeros of this particular polynomial x square plus px plus q, then we need to find p and q. Again we know for a standard polynomial ax square plus bx plus c equal to 0, sum of root is minus b by a, product of roots is c by a. So what is sum of the roots? P plus q. And what is b by a? Here a is 1, b is p, c is q. So sum of the roots will be minus p, and a is 1, so minus p by 1, so which is minus p. Product of the root is pq. What is product of q? C by a, c is q, q by 1 is q. So we got this. Two expressions we got, so we need to compute p and q from that. Let us take this particular equation and take q on the left hand side. So we'll get pq minus q is 0. Q we can take common. If these two expression product of two term is 0, then one of them is 0. Either this or this is 0. If q is 0, you can write q is 0, or p minus 1 is 0, which is p equal to 1. So we got, let us put p equal to 1 here. When p equal to 1, this will be 1 plus q equal to minus 1. So q will become minus 2. And when we put q equal to 0, the second one, when we put q equal to 0 here, p will be 0. So there are two solutions. P equal to 1, q equal to minus 2. Another solution is p and q both are 0. Friends, with this we conclude this chapter on extra questions, extra punch questions on polynomials. I request you to please subscribe my channel and give a thumbs up to this video. This will motivate me to make more such good videos for you. Thank you, friends.